flies, dragonflies, which had 4 wings. So the fruit fly, through changes in genes, it's as if they flip the channel, and these developing structures develop into wings, not whole hairs. It's like flipping a channel on your TV set. They affect a switch. But you can produce the same effect, for reasons no one understands, by changing the environment of fruit flies. If you expose 3-hour-old fruit fly eggs to fumes of ether, I now mean diethyl ether, the anesthetic, the flies that develop, some of them develop with 4 wings instead of 2. This is a developmental abnormality, a bit like thalidomide causing human abnormalities. Without genetic change, it just affects it disturbs development. Now, it was discovered by Waddington, the man who put forward the creode idea, that if you keep doing this generation after generation, more and more flies develop abnormally. He thought at first it was a genetic selection effect, but the experiment was repeated at the Open University by Dr. Mei Wan Ho and her colleagues. And over a series of generations, with an inbred strain where you could have no genetic selection effect, they looked at the proportion that went, these are the generations, this is the proportion with 4 wings. First generation about 2%, the next generation about 7%, and so on until they got up to about 35%. And in some cases they stopped exposing the eggs to ether, but still for generations, at a declining rate, they went on forming 4-winged flies. The interesting point from my point of view is this. After they'd done this, at the time of the 10th generation, they got some fresh flies of the same strain. They exposed them to ether. The first generation were transformed to 10%, the second generation to 20%, compared with 2% and 6% the first time round. After all these flies had developed abnormally, it became easier for other flies to show the same abnormal form of development. And I would say that was because of morphic resonance. It has nothing to do with genes, and there was no genetic connection between the new batch of flies and the ones that had been treated previously. Now, the same principles apply to the organization of nervous activity and learning. The theory predicts that if you train rats to learn a new trick in one place, like London, rats all over the world should learn the same thing more quickly, just because the rats here have learned it. There's a kind of collective memory. And when I first thought of this, I thought if that's true, people should have noticed this. They're training rats to learn new tricks all the time in labs. I looked in the rat literature, and I found that, in fact, this was already observed in a fascinating series of experiments started by William McDougall at Harvard in the 1920s. Rats were trained to escape from a water maze by swimming to an exit. If they swam to the wrong exit, they got an electric shock. I mean, it's one of those old-style give them shocks type experiments. No one would do that today, luckily, but anyway, he did it then. What he found was that the first generation of rats made hundreds of errors before they learned. He bred from them, and the second generation made fewer errors, and the third made fewer still, and so on. And he thought he'd shown an inheritance of acquired characteristics. Those of you who studied biology will know that this is the ultimate heresy in biology. You're not meant to have an inheritance of acquired characteristics. What the parents do is not supposed to affect the offspring, because it's all supposed to be coded in the genes which are passed on unchanged. We've seen from the fruit flies that's not true. The changing development of the parents did affect the offspring, and indeed all other flies of that breed. And the same happens. What was happening with McDougall's rats is he thought it was genetic. And some of his critics, it was very, very controversial, the critics said, oh, well, there's just a flaw in your experiment. You're breeding from these rats, so obviously you're taking the ones that learn quickest as the parents, because you can breed the next generation sooner. And you're unconsciously ignoring the stupid ones that take a long time to learn, so it's just ordinary genetic selection. Everyone seemed pleased by that, it was conventional. But McDougall came back and said, okay, I'll test that theory. In every generation, I'll take as the parents of the next generation the most stupid rats, the slowest learners. Genetic selection should mean they'd make more and more errors as time goes on. This is what happened. The number of errors fell generation by generation from over 200 to start with down to about 30. And this was with stupid rats. It should have been going up like this, the number of errors. In fact, they were getting better and better as time went on. What was happening? Genetic selection couldn't explain this. People were outraged, and people tried to repeat his experiments in two universities, Edinburgh in Scotland and Melbourne, Australia. They started off with similar rats, and when they started training their rats in the same apparatus, they started where the Harvard rats had left off, around here. The ones in Scotland got better and better. Even so, they started off learning faster, and then people said, well, there must be something wrong. And the Australians said, OK, you haven't included control rats. In every generation, we'll test not only ones descended from trained parents, but rats from a standard line, the same breed, whose parents have never been exposed to these water mazes. What they found was that both lots got better and better. And that proved it wasn't genetic. It was nothing to do with modifying genes. So everyone heaved a sigh of relief and said, OK, this refutes Lamarckian inheritance, nothing to do with modifying genes, and the whole episode was closed. And these data were left gathering dust in the archives. But nobody explained the effect itself. The effect itself fits perfectly with morphic resonance. Now, the same should apply to human beings. It should be getting easier and easier to learn computer programming, windsurfing, paragliding, and every other sport and skill that's come on the scenes in recent years. Actually, people do seem to get better at learning them, but it could be improved educational videos, better training techniques, new technologies, seeing it on TV. There's lots of factors that affect this. To study this, you need to have standardized experiments or observations where the same test is done over and over again. And in the 1980s, I realized that one perfect source of data for this would be IQ tests. IQ tests have been done in much the same way over many, many years. And morphic resonance would predict that people should be getting better at doing IQ tests, not because they're getting more intelligent, but the tests should be getting easier because so many people have already done them. And I couldn't get hold of the data to test this, but luckily a New Zealand scientist called James Flynn took up exactly this question and found that just this sort of thing was happening. This shows the rise in average IQ test scores in the United States from 1918 to 1989. And as you see, there was a dramatic and puzzling rise in IQ test scores. Not to be outdone, people have found that the same has happened in Britain, Germany, Japan. In fact, everywhere people have looked, they've seen the same rising IQ score effect. This is now called the Flynn effect, after James Flynn. And what is the explanation? There's been tremendous controversy within the psychology world. People at first said, well, it must be better nutrition, it must be urbanization, and so on. But none of these things worked out in explaining it. People investigated different countries, and they found that these might explain a small part. Being more used to doing tests at school, television making people smarter. Well, no, most people thought it made them dumber. None of these explanations have been hundreds of papers in the psychological literature battling out over this, and no one can explain it. It's exactly what you'd expect on the basis of morphic resonance. Now, you can do special tests for morphic resonance, and I'll talk about one or two of those in a moment. But a very interesting new kind of test came up just a few years ago. Our oldest son, who was then 16, was doing GCSE, and he came up to me one day and said, I and my friends have been discussing our GCSE exams, and we've come up with an idea of boosting our scores with no extra effort. And I said, well, that sounds good. How are you going to do that? And he said, by morphic resonance. So I said, well, how's that going to work? He said, take the physics or maths exams. There are 16 questions. We're going to do questions 15 and 16 first, and then go back and do 1, 2, 3, 4. That way we'll be 10 minutes behind everyone else in Britain, and we'll get a boost from morphic resonance. Well, I said, I'm all too familiar with the dynamics of morphic resonance discussions. I said, there must have been a skeptic in the room who said, what if morphic resonance doesn't really happen? And He said, yes, indeed, there was someone who said that. And he said, we worked it out that if it doesn't happen, we wouldn't lose anything, but if it does, we'd get extra points. And they all did it, actually, and did rather well in their exams. This suggested to me a whole new way of testing for morphic resonance. And as it happens, the head of the Cambridge OCR, Oxford, Cambridge and Royal Society of Arts Science Examination Board, is an old friend of mine from Cambridge. And I suggested to him that they could, just by changing the order in the science exams, turn the whole of Britain into a national laboratory for morphic resonance testing. He loved the idea, but he didn't dare implement it. But when I was talking about this in a lecture in Holland, I was amazed at the reaction of the audience there. What people said to me is, they looked at me incredulously and said, in England, does everyone do the exams in the same order? The questions in the same order? I said, yes. They said, oh, we don't here. They said, the exams come in two alternative versions, A and B. There'll be questions 1 to 8 and 9 to 16 in one paper, but the other version has 9 to 16 and now 1 to 8, and the others at the other one. And I said, why? And they said, so people sitting at adjacent desks, they get papers A, B, A, B. They're always sitting next to someone answering a different question, so they can't cheat. So the entire Dutch national examination system is in fact set up as a morphic resonance experiment. And my friend and colleague Dick Beerman at the University of Amsterdam has already examined 8 papers from the psychology exams in the University of Amsterdam. In 7 out of 8, the questions done afterwards had higher scores than those done before. His assistant is now examining a whole range of going into the archives and getting out a whole lot of new exam results, or old exam results rather, from the university. And then if that works, we could try and do it with the entire Dutch school examination system. So luckily, this experiment has actually already been carried out for totally different reasons. Now, there's a number of tests I've been trying over the years for morphic resonance. One of them involves puzzle pictures. Now, take a look at this picture, and hidden within it is a hidden image. I'm going to show you the answer in a moment, and I'm going to ask you to tell me if you spotted it. Very few of you will have done. That I predict. Okay, here's the answer. And here's the image again. Now, how many people got that? Oh, yes. So it's probably about 4 to 3%, something like that. It's about the average level. Okay, here's another one. Okay, here's the answer. Now, how many of you got that one? A few more, yes. Good, thanks. Well, this is an experiment, one of my first experiments for morphic resonance. It was done on TV. And what we did is we had 2 puzzle pictures like this, which were very difficult ones. We tested groups of people in Germany and in other parts of Europe. And we found out how many could recognize the hidden image. Then one of them was selected at random and shown on BBC television, in fact on Tomorrow's World, to 8 million viewers. And they were all shown the answer. So 8 million people got it, just like you've got it. This is a very rapid form of learning. If you see these pictures again in a year's time, you'll probably get them straight away. The question was, did it make it easier for people to get that picture on the continent? We tested fresh batches of people there, and sure enough, the one that had been shown in Britain became easier to recognize in Germany than the other one. We then did it again on ITV, and it worked very well the second time. These results were published in New Scientist and so on. And then German television wanted to do it, so they asked me to do a third experiment where the pictures were shown in Germany, and we tested people here in Britain. Well, that gave a terribly puzzling response. I predicted that it would make it easier for people to recognize the puzzle picture in England when the Germans had seen it. The skeptics predicted there'd be no significant difference, no effect at all. Nobody predicted that Germans seeing it on a Sunday afternoon would make it harder for people in England to recognize, but that's what happened. So there was an effect, but it was a completely puzzling effect that no one's been able to explain. And it slightly set back this line of research because, although it gave very interesting results, these are